All right. All right, we're looking at prime and composite numbers. Okay, prime and composite numbers. All right, prime numbers. Prime numbers are those numbers that have exactly two factors. Okay? Prime numbers are those numbers that have exactly two factors. Okay? The number 1 and itself. Okay, the number 1 and itself. Composite numbers are those numbers that have more than two factors. Okay, so we have prime numbers and we have composite numbers. Now, let's remind ourselves what factors are. Okay, the factors of 12 are 1, 2, 3, 4, 6, 12. Okay, factors are those numbers that you can multiply together to get that certain number. Okay, you have the factors of 36. Factors of 36 would be 1, 2, 3, 4, 6, 9, 12, 18, 36. Okay. Now, factors of 2. Factors of 2 are 1 and 2. Factors of 3, 1 and 3. Factors of 5, 1 and 5. Okay. Factors of 7, 1 and 7. Okay. So those are all factors. Factors are numbers that you multiply together to get a certain product. All right. Now, we obviously have two distinct types of numbers here. Okay. These would be composite numbers. These would be prime numbers. Okay, everybody see why one's prime and one's composite. Okay. Now, the first few prime numbers is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and they go on forever. First few composite numbers would be 4, 6, 8, 10, whoops, missed one, 9, 10, 12, 14, 15, 16, 18. Those are the first few prime numbers. Okay, you can see there. You can see in your composite numbers that you have both even and odd numbers. Okay, you can see in your prime numbers that you only have one even prime number, and that's 2. Okay? The rest of them you don't have. Okay? The rest of them are odd. Now, just because a number is odd doesn't mean it's necessarily prime. As we've said right here, 9 is not prime, 15 is not prime, 21 is not prime, 27 is not prime. Okay? There's a lot of, 25 is not prime. There's a lot of odd numbers that are not prime, but there's only one even number that is prime. The reason being is because of this. Let's look at the factors of 4. The factors of 4 are 1, 2, and 4. The factors of 6, 1, 2, 3, 6. The factors of 8. Factors of 8, 1, 2, 4, 8. Well, you can see that every single one of those even numbers have 2 as a factor. So we know that all even numbers will have 2 as a factor. So that automatically makes them have at least 3 factors. Okay, just like 4. 4 has 1 and itself, and then the factor of 2. Okay, that's why 4 is not prime, because it has more than 2 factors. Okay? Now, so, let's look at a couple of numbers and how we're going to list their factors. All right, let's look at 20. So I want to know the factors of 20. Okay, the factors of 20. I have found a way that I like to do it, and maybe this will help you. Okay, I'm going to put 20 right there, and then I'm going to draw a T. On this side of the T, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I'm going to ask myself, does 1 go into 20? Yes, 1 goes into every single number 20 times. Does 2 go into 20? How many times? 10 times. Does 3 go into 20? No. Does 4 go into 20? 5 times. So I've already used 5, 6 doesn't, 7 doesn't, 8 doesn't, 9 doesn't. I've already used 10. So my factors of 20 are 1, and I'm just going right here, 1, 2, 4, 5, 10, 20. There's your factors of 20. Now, obviously the 10 is already right here, so I don't need to really go down there. You will see that I started at 20, then 10, then 5. So there's 10, there's 5. Okay, so I don't need any of these in here because I know 5 and 10 go into it. Then these don't go into it if there's nothing else, if they're not already listed. Okay, and so that way I list them 1, 2, 3, 4, 5, 10, 20. I just work myself in a little U right there. Okay, let's look at another example. Let's see here. Let's look at 54, the factors of 54. Okay, the factors of 54. So once again, I'm going to put 54 there, and I'm going to draw me a little T. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1 and 54. Okay, does 2 go into 54? How many times? 27 times. Does 3? What's 5? What's 5 plus 4? 9. Does 3 go into 9? Then 3 has to go into 54. 3 goes into 54 18 times. How about 4? Well, 4 times 10 is 40. 4 times 11 is 44. 4 times 12 is 48. 4 times 13 is 52. 4 times 14 is 56. So it doesn't go in it. So I mark it out. Does 5? No, because it doesn't end in 5 or 0. Does 6? Yes. 6 goes in it 9 times. So I can mark out 7, 8, 9, and 10. So now I have 1, 2, 3, 6, 9, 18, 27, 54. And those are your factors. Gabby? Well, because I already know right here is 6 and 9. So there can't, since 6 times 9 is 54, 7 and 8, there can't be a number that can, it'd have to be 7 times 8. And so I can just mark out 7 and 8. I've already used 9, and I've already gone from 9 and 18 right here, so 10 can't be used because I've already passed 10 on the other side. I've already passed 10 on this side by going from 18 to 9, so 10 can't be a factor of it. Plus, it doesn't end in 0, so 10 can't go into it. Yeah, that's all we're doing is finding all the that's this part of it. We're not to the prime factorization yet. That's what this part is. Okay? Now, next part, prime factorization. Okay? With prime factorization, we're going to use factor tree or inverted division. Factor tree or inverted division. Okay? All right. Now, factor tree or inverted division, if I'm going to prime factor, let's say I'm going to prime factor 24. Prime factorization okay? Prime factorization is the product of the prime factors of a given number. So if I'm going to prime factor 24, okay, the factor tree method means I find 2 factors of 24. What are 2 factors of 24? 6 and 4. Okay, what are 2 factors of 6? 2 and 3. 2 factors of 4, 2 and 2. Those are all prime. So the prime factorization of 24 is 2 to the 3rd power times 3. Okay? Inverted division. Inverted division, you can only use prime numbers. Okay? You can only use prime numbers. So what is my first prime number? 2. 2 goes into 24 12 times. Does 2 go into 12? So I divide 2 into 12, goes 6 times. 2 into 6 goes 3 times. There's your prime factorization. 2 to the 3rd times 3. I do not care which way you use. Whatever way you think you understand the best, then use that way. If you want to use the factor tree for smaller numbers, that's fine. And use the inverted division for larger numbers, that's fine. Okay, Gabby?
On this side,
on inverted division?
Yeah.
Okay.
Right here?
Yeah.
Do they have
You have to, well, you just keep using it until it won't be, you can't use it anymore.
Oh, so you keep, like, multiplying it?
Yeah, I just keep dividing 2 into it. If 2 will just keep going into it, then you divide it until you end up, what you want to end up with is your last number has to be prime. That's when you stop. Okay? For example, if I had 64, 64 is 2, 32, 2, 16, 2, 8, 2, 4, 2, 2. Okay? So that's 1, 2, 3, 4, 5, 6. 2 to the 6th power. Okay? If I did 64 with the factor tree, okay, 8 times 8. That would be 4 times 2. That would be 2 times 2. 2 times 2. Circle all my prime numbers. And it's still 2 to the 6th power. Okay. Brandon?
Like, what if our inverted number is 21? Do we use 3 instead of 2?
Yeah. Yeah. If it was like, let's say it was 165. Okay. Well, 2 doesn't go in 165, but we know since it ends in 5 that 5 does. The only thing you have to do is they have to be prime on the outside of the inverted division. They have to be prime numbers. In other words, I can't do 64 and start off with 8 right there. You can't do that with inverted division. Okay? You can with factor tree, but you can't with inverted division. Kennedy?
Do we always just use power?
Yes. If you've got more than, if you've got 2 to the 2nd power, you need to focus. Taking notes, not writing Spider-Man. Okay? Yes, you always have to write it in with exponents. Okay? Let's look at this one. Prime factorization of 588. Okay? And this is where, real honestly, a lot of you need to just do inverted division. Because for you to sit there and try to figure out the factors, 2 factors of 588, you're gonna waste time and it's gonna take you a while. Okay? So you just divide. It ends in 8, so 2 goes into it. 2 into 5 2 times, remainder 1. 2 into 18 goes 9 times. 2 into 8 goes 4 times. 2 into 2 goes once. 2 into 9 goes 4 times, remainder 1, 7 times. Now, 2 doesn't go into 147, but our shortcut says 1 plus 4 plus 7. 1 plus 4 is 5, plus 7 is 12. Does 3 go into 12? Then 3 will go into 147. 3 goes into that, let's see, 49 times. What goes into 49? 7. So your prime factorization of 588 is 2 to the 2nd times 3 times 7 to the 2nd. Okay, and that's your answer. To be real honest with you, factor tree, it'd be hard for me to come up with 2 factors besides just dividing 2 into it. I know 4 goes into it because it's 88, but so with the smaller ones, then maybe you need to use factor tree. Hey, Sean, do you have a question or are you just stretching? In inverted division, I just keep using it until it won't be, I can't use it anymore. Well, when I switched off, for example, I went 2 into 588, it's even, okay, it's not even. So now I need to look at my next prime number. My next prime number after 2 is 3. Okay? If 3 doesn't go into it, then I look at my next one, 5. Well, it's got to end in 5 for 5 to go into it. And so that's what I do, is I just keep going, and most of the time, you're going to run into ones that there may be occasionally where you have, like you may think it's prime and 17 goes into it. Okay? A good example of one everybody think is prime, and we talked about this last year, is 51. 51's not prime. Because what's 5 plus 1? 6. Does 3 go into 6? Then 3 goes into that 17 times. So the prime factorization. Now, you will understand that the prime factorization is not this listed out. The prime factorization of a number is the product. So it's got to have multiplication signs in there. Okay, this is not the answer. That is not the answer to that problem. This is the answer. Okay? It's not just listing out all the prime numbers and saying that's my answer. Okay, so make sure you don't do that. Let's look at 612. Another one that you would probably have issues with trying to come up with two factors. So just start. I know 2 goes into it. 2 goes into 6 3 times. Does 2 go into 1? No. So that'd be a 0. Carry it over there. 2 into 12, 6 times. 2 goes into 306 because it's even. 2 goes into 3 1 time. Remainder 1. 2 into 10, 5 times. 2 into 6, 3 times. 2 no longer goes into it. Does 3 go into it? Yes. 3 goes into 15 5 times. 3 goes into 3 1 time. And we just proved that 3 goes into 51. So your answer is 2 to the second times 3 to the second times 17. Okay? Gabby?
Is there a specific limit that, like, you can't have 2 to go of a number, like, right here at the bottom? Or is it just...
No, it's just you're going to end up with a prime number there if you do it properly. You will not, and what a lot of people do is they take that one step further. Like this one, they'll take one step further and put a 17 there and put a 1 there. No, 1's not prime. So you stop when you get to the prime, which is 17. So this is prime, so that's where you stop. Isaiah?
How did you get 2? How do you get the subtraction sign?
It's not a subtraction sign, it's a multiplication sign. That's the dot. Multiplication dot, multiplication dot. All right, now, I want you to look at number 18 on page 159. Number 18 on page 159. Okay? The directions for 18 through 27 says, tell whether the number is prime or composite. Explain your reasoning. You don't have to explain your reasoning. You just have to tell me whether it's prime or composite. Okay? You tell me whether it's prime or composite, and you move on. Is 88 prime or composite? Composite. Why is it composite?
Because you could multiply 4 into it.
Right, but it's because it's even, and it's not 2. That's the reason. I mean, it has more. I mean, all of them are going to be either it has 2 factors or it has more than 2 factors. That's your reasoning. Okay, but the reason why 88 is because it's even. The next one is 23. Is 23 prime or composite, Quade?
23 is composite.
What factors go into 23?
Oh, 8.
8?
Yeah, 8.
No.
What?
8 only goes into even numbers.
Well, 8 go, oh, wait. 23, yeah, 1.
Okay, so it would be prime. It would be prime because it only has 2 factors, 1 in itself. Okay? The next one is 61. Is 61 prime or composite? Prime. 39, is it prime or composite? What? Composite. Because 3 times 13 is 39. So it got more than 2 factors. Okay, so you get the idea of what you're doing there. Okay? Now, your homework. 4.1, 8 through 30. And 35 through 44. Okay?